When we picture the monumental remains of ancient Egypt, our minds almost instantly jump to the Great Pyramids, right? Or the towering obelisks, or those sprawling, labyrinth like temple complexes. Those iconic structures have absolutely stood the test of time. They project the power, the ambition, and really the sheer architectural genius of an empire across millennia. But, behind every perfectly polished statue and every colossal stone pillar, there is a much grittier, largely hidden story. I'm so glad you're joining me for this explainer because today we're going to explore the massive, back-breaking industrial machine that made all of that ancient splendor actually possible.
So let's just jump right in by asking the fundamental question that bridges the gap between those pristine pyramids and the raw earth they were literally carved from. We all know exactly what the ancient Egyptians built, but where on earth did they get all the stones? How did they manage to find, extract, and transport millions upon millions of tons of solid rock to their building sites?
Think about the incredible contrast here for a second. On one hand, you have something like the breathtaking Philae Sandstone Temple, a total masterpiece of refined ancient masonry and design. But to get that, you have to start with the rugged, open-cut workings of a site like the Nak El Fugani Sandstone Quarry. It's a pretty powerful reminder that long before there was breathtaking architecture, there was immense, exhausting industry out there in the harsh Egyptian landscape. To make sense of it all, here is our roadmap for this explainer. We're going to look beyond the pyramids, dig into Egypt's geological canvas, see how they matched builders and carvers to specific materials, detail their actual extraction technology, and finally, uncover the enduring legacy of the quarry workers themselves. All right, part 1, Beyond the Pyramids, where we are uncovering the true scale of stone extraction. Get this. Researchers have actually discovered over 200 ancient Egyptian quarries, mostly scattered along the Nile Valley and out in the eastern desert. And this wasn't some short-lived project either. These sites were continuously worked over a mind-boggling span of about 3,500 years. We're talking all the way from the late pre-dynastic period straight through to the late Roman period. Which brings us to part 2, Egypt's geological canvas. This is quite literally the foundation of the empire. To truly grasp how this empire was built, we have to look at the bedrock. It is absolutely fascinating how neatly the geological timeline dictated their building materials. The oldest layer, the Precambrian era, provided the crystalline basement rocks. These are your incredibly tough igneous and metamorphic hard stones. Move a bit forward in time to the Eocene epoch, and you find the younger, softer sedimentary rocks, like limestone. And then from the Cretaceous period, we get the massive sandstone deposits. The ancient Egyptians essentially looked at this geological timeline and treated it like a massive open-air hardware store. And they were smart about it, too. Take the Wadi al-Muluk limestone quarry over in western Thebes, for instance. The Egyptians didn't just dig randomly. Their quarries were highly strategic. This particular massive limestone quarry was positioned perfectly to supply the exact stone they needed for magnificent structures right nearby, like Queen Hatshepsut's famous temple at Deir el-Bahri. They kept the supply chain as short as humanly possible. So moving on to part 3, builders, carvers, and jewelers. It was all about matching the stone to its specific purpose. See, the Egyptians strictly differentiated between the foundational, structural building stones and the super hard, flashy, ornamental pieces they used for the details. When it came to raising the main walls, the bread and butter of Egyptian construction was divided geographically. If you were building up in the north, middle, and lower Egypt, you used the Eocene limestone that was basically everywhere. But if you were building down south in Upper Egypt, your go-to material was the Cretaceous Nubia Group sandstone. These two softer stones were the literal building blocks of the empire's grandest temples and tombs. But what about the flash, the show-stopping details? For that, they needed stones with vibrant colors that could hold a high polish. These hard, ornamental stones, stuff like granodiorite, basalt, and travertine, were in massive demand. They used them for those gleaming external pyramid veneers, the very peak pyramid capstones, intricate Burke shrines, those imposing colossal statues, and, of course, massive sarcophagi and delicate canopi jars. Okay, part 4 is where things get really kinetic. Ancient extraction technology, a wild mix of brute force and delicate skill. Just imagine trying to pull a multi-ton block of stone straight out of solid bedrock without a single piece of modern machinery. It's almost unthinkable. But at quarries like Gibel el-Silsila and Nag el-Hosh, the evidence of how they did it is literally carved into the walls. If you visit, you can clearly see these explicit vertical trenches and the dressed chisel marks left behind.
You're basically looking at the negative space where a giant block of stone was painstakingly isolated, snapped free, and hauled away. But how they got it out depended entirely on what kind of stone they were dealing with. There's a direct contrast here. For hard stones, it was mostly a matter of sheer brute force. Workers would use these handheld dolerite pounders to literally smash away the rock, often using fire setting to heat and weaken the stone first. But soft stone quarrying, that required precision. Workers used copper or bronze picks and chisels to carve incredibly deep, narrow vertical trenches, and then they'd carefully undercut the block at the base to snap it free. And over the 3,500 years this industry was running, their tech definitely evolved. Back in the late pre-dynastic era, they relied almost entirely on stone pounders and soft copper. Moving into the dynastic era, bronze came along and provided a slightly tougher edge. But the real game changer happened in the late period when they introduced iron sledgehammers and wedges. That eventually evolved all the way to the Roman era, where they introduced the highly precise pointillé splitting technique. That's where a straight line of shallow pits was chiseled into the rock until it split perfectly along the seam. Yet, even with all those changing tools over thousands of years, the human element remains deeply, intimately visible. Even today, in some of these Entergard galleries, you can still see the ancient red guidelines painted directly onto the ceiling by the overseers. These lines marked the forward progress of the quarrymen working deep inside the rock. It gives us this incredible, tangible glimpse into the everyday, dusty, and honestly exhausting work of these ancient laborers. Which perfectly sets up our final section, Part 5. The quarry worker's legacy, the silent ruins of industry. You see, these 200-plus extraction sites across Egypt aren't just empty pits. They are rich archaeological ruins in their own right, holding stories that are honestly just as important as the temples they helped build. As the authors of our source materials so perfectly put it, ancient quarries are more than just sources of stones, but are also rich archaeological sites with ruins and other cultural remains. Preserving and studying these hidden landscapes gives us a totally unfiltered perspective on the lives of everyday workers, a side of Egyptian history that's way too often overshadowed by the pharaohs they served. So I want to leave you with this thought to chew on. While the kings and pharaohs get all the glory, and it's their names carved onto the polished obelisks, the true architects of the Egyptian empire left their enduring, permanent marks deep within these remote, hidden landscapes. The actual builders of Egypt are etched into those very cliff faces. Thanks so much for joining me as we dug into the foundation of history on this explainer. Keep wondering, and we'll see you next time.